Hello again, class. Welcome to a new day, a new week. That's the last week of the month of April. We thank God for keeping us throughout the month, and I'm happy to welcome quite some dignitaries into our midst here. I'd like to welcome, in particular, Professor Jofu Sanamo Mensah, former Vice Chancellor of the first University of Education in the whole of Africa. From Ghana. He's based in Ghana. That's University of Education Winneba in Ghana. For the top three overall from the Burundi group is Masirika Matunguru Joseph. Congratulations. Also the first prize, because the Roger had the same score, total score with Matunguru Joseph. He also came first. And then the third, because we have two firsts, this cannot be second. This other David will have to be third. That's overall for the Burundi group in week 3. So let's look at the Nigeria group. For the Nigeria group, the overall is Adekunle Oladejo and Onowubeda Franklin. They both came first. And the Gbeleyi is coming up very good. Olasunkami Gbeleyi came third. So congratulations also to the Nigeria group. Now, overall, ladies and gentlemen, we had 4 people coming first. So it is a wonderful race for this week. Matunguru, Joseph, Masirika, 47. All of them scoring 47, so all of them came first. Oladejo, Onowubeda, and Roger. I congratulate you one and all. Now, let us welcome our first facilitator. Who is first facilitator is no other than Professor Olatunde Owolabi, who is a professor of physics education in the Department of Science and Technology Education and the Deputy Center Director of this center running these courses, Africa Center of Excellence for Innovative and Transformative STEM Education, Lagos State University. He has been at the frontier of science education reform in Nigeria and also a former consultant to UNESCO. He's a regular facilitator in the teaching of research methods, educational statistics, and contemporary issues in science education within and outside this university. His research interests traversed the following areas of science education: language factor and development of curriculum and learning protocols. He's presently researching indigenous knowledge systems. I'm sure that Professor Jofu Sanamo Mensah will be happy to know that, with special focus on CTA strategy in STEM education. He's also a member of the National Association for Research in Science Teaching, NAST, and also of STAN. He was the national chairman of the physics panel. My pleasure to welcome Professor Olatunde Owolabi, who used to be my head of department. He was a great head of department, and by God's special grace, he will be our incoming dean. Professor Olatunde Owolabi, you have the floor.
Yeah, good morning, everybody. You are welcome to today's class on conducting pure and facile experimental research. May I first welcome our eminent professors from everywhere, most especially Professor Duma Kabani and Professor David. Of course, I welcome participants from Burundi, from Ghana, and of course from DR Congo. I caught this snap when they were on board and before they touched at Murtala Mohammed International Airport, right there in class. So I want to welcome all. Permit me to first appreciate 2 icons. First, distinguished Professor Peter Okebukola, the doing of higher education in Africa. I want to place it on record, your absolute leadership quality, your academic wizardry, and most importantly, your superb mentorship. Whereas you are mentors to many academic juggernauts in the world, as attested in previous presentation. But to us at ACEITSE, you are mentor extraordinary and father. It may interest you to know that we refer to him as Baba. Baba means father, and Baba as a father is something you can always be proud of. Any day, anytime, is a father, and I want to appreciate. Secondly, is a distinguished professor, eminent vice chancellor, a God gift, a reformist, and an excellent administrator in person of Professor Lamiwaju Adigunfago. To both of them, I owe you a lot of regard, and I say thank you. Now to the lecture of the day. I want to start by first taking your mind back to your days in school when you had an experiment on phototropism. I want to let you know that you can only say you have an experiment if there is a check and balance somewhere. And by check and balance, I mean a control. Before you can say there's an experiment, it means you have at least two groups. One, the control group, and the second, of course, the experimental group. You give treatment to the experimental group while you keep watching the control group growing and compare against the treatment in the experimental group. So that if there are changes, you can say, yes, these changes can be attributed to the treatment given to the experimental group. That is the idea of experiment. And in research, I want to say in experimental research, that is the idea. Now, when do you conduct an experimental study? You conduct an experimental study when you are trying to determine the effectiveness, the efficiency, or the efficacy of a treatment. A treatment can come in form of a method, it can come in form of an innovation. For instance, just last week, distinguished Professor Peter Okebukola was amazed with the performance of most presenters, especially the technology we are using, Zoom. And he made it known to us that Zoom will be something that will be installed at now, National Open University of Nigeria. He will not just go to NAN and dialogue with the Vice Chancellor there and they begin installation. No, they must do something like a trial test. In doing the trial test, of course, the best way to go, the best design will be experimental. Their normal way of teaching will be the control, while using Zoom will be the experiment. And through that, there will be comparison, and at the end of the day, we will see whether, okay, Zoom is better than what they were using.
Yes, sorry, Professor Owolabi, we are receiving feedback from the chat window that they are not hearing you. If you want to speak, they say you are not loud enough. I don't know whether you can tackle that from your end.
Okay, thank you very much.
Better, exactly, better.
Yeah.
They
in
didn't hear much.
Study,
okay,
it's not just a study you conduct anyhow. There's a popular joke among some academics that in education, in research, what they do is to count chair, biro, and table. Such people should better come and listen to this lecture or go read about experimental design. They will now appreciate how rigorous experimental study could be. Before you can conduct, you must first have very deep knowledge of experimental study. There must be two or more groups. And in experimental study, there will always be deliberate manipulation of the independent variable in order to determine the effect on the dependent variable. It is therefore referred to as a cause and effect relationship. I want to take your mind back to some other designs, the expo factor, which is also cause and effect. In this case, like I said, deliberate manipulation. In expo factor, you observe the situation in situ without any manipulation of independent or any variable and see whether there will be changes, natural changes, independent. But in this one, there is always deliberate manipulation of the independent variable. What are those things you need to bear in mind? First, pure experimental study. You can only say a study is pure provided sampling is done by randomization. I want you to watch this. I have listened to students, even to some colleagues present during graduate seminar or at conferences, and you see them saying the design is pure experimental. But when I look at their sampling, you find out that sampling was not selected by randomization. No, that cannot be pure research, pure experimental. For pure experimental research, your sampling must be by randomization. And like I said earlier, there must always be a control. You should also bear in mind that in most cases, experimental study may require just few subjects when you compare to some other design like survey, where you have many subjects involved. What are those things that should interest you in experimental study? The first one should be that it's about generalizability of the finding. In most cases, findings of experimental study are not easily generalizable. And I will tell you why. In a short while, you are going to see why. But in most cases as well, if they are generalized, it's always to the homogeneous group and not to the heterogeneous group. You should know this, that in experimental study, every design comes with a statistical tool, recommended statistical tool. In most cases, but not at ACEITSE, you see students trying to secure the service of vendors to analyze their data and all that. And because they are statistician one, maybe they are highly proficient in the use of the system, they will feel they will do justice. And they just do anything, and at the end of the day, they don't get good findings. So for experimental study, bear in mind that every study comes with inherent statistical tool. Now, I said earlier that experimental study are not usually generalizable. Why? It's because of two things. What are those two things? Threats to the study itself, to the finding. These threats are internal validity and external validity. When you are talking about internal validity, you are referring to the soundness of the study. You are saying the extent to which those factors, the independent variables, have direct effect on the dependent variable you are seeing. For external validity, you are also talking about what? You are talking about the extent to which that study can be extended to other populations or even to other treatments. Yes, let's discuss about those threats. The first one, for internal validity, we have nine threats to internal validity. And the researcher must have deep knowledge of this and be able to control them for your findings to be sound. The first one is history. In the case of history, you are looking at a situation where the experiment is prolonged. And of course, in the process, some external factors may come in, which may jeopardize the result. Maturation is quite related to history. In the case of maturation, as you go along with the study, you are getting more mature, you are getting more wiser. And this, of course, may have some consequences on your finding. Selection bias. In the case of selection bias, so easy. We said for experimental study, you must have at least two groups. If those two groups are not of equal ability, or you as a researcher, you have not established equivalence of the two groups, then you must have introduced that threat that we call selection bias. Unstable instrumentation. This is quite interesting. We have listened to many lectures on validity and reliability of your instrument. If your instrument is not valid and reliable, it means the instrument is poorly developed. And of course, you'll have introduced what we call unstable instrumentation. Testing. In the case of testing, we are referring to a situation where you pre-test your sample before treatment and after you post-test. This, of course, can also affect the internal validity. And I want to draw your mind to what is going on here. Just a few days ago, our distinguished professor changed the mode of administering questions for you. Why? Because he was of the opinion that, the effect of testing will give undue advantage to some people. So the key to those questions will not come immediately after the questions are administered or expiration of the time, but delayed a little more to avoid this issue of testing. Statistical regression. In this case, you have at hand a situation where you have students who are high performers and students who are low performers. The moment your sampling is done such that you consider those students, you have introduced what we call statistical regression, because it will affect finding. Experimental mortality, in this case, we are talking of loss of sample. We said establish equivalence of group. If in a group, some candidates drop out, of course, it will affect the overall result, and that's experimental mortality. Interaction of selection and maturation. There are cases when you are familiar with your students. For instance, a year before, you took them on a field trip for a concept in ecology, and the students really had enough fun. So in the following year, maybe for reasons best known to you, you decided to say, okay, instead of field trip, let me come with those apparatus to the class and let me share it. And the students were like coming to you to say, sir, last year they went for a field trip now. Why is it that it's during our time that we'll be having this topic in class and all that? And of course, you succumb or you don't succumb. By doing, it will have affected the finding of the study. So that's what we call the interaction of selection and maturation. Experimental bias. Yes, experimental bias is sometimes introduced in the study. How? It's introduced when a teacher is too familiar with the students. It's quite related to the first one. When you are too familiar with the students in an experimental study, you as the researcher, you decided to involve the teacher teaching those students in your study, maybe as a research assistant. So the teacher is the one administering the treatment. It will have effects on your findings. And that's the effect is what we call experimental bias. What are those threats to external validity? There are four. The first one is interference of peer treatment. What do you mean by this? In a situation where you have a group, you observe, you give treatment, and after treatment, of course, you give process. So the same group, you now administer your control. In this situation, you'll have introduced some threats to the study, which we refer to as interference of interference of the treated on the final result. Interaction effects of testing. I've earlier mentioned this. In a situation where you pretest, it has some effects on the result, if not control. Interaction of selection and treatment is another very good thing. In this case, you have your subjects, and the subjects perhaps are well known to you. You now administer your treatment to them. And because they are well known to you, it will have some effects which will influence the result of your study. Extent of treatment verification. In this case, you involve graduates, you involve research assistants in your study. And the research assistants are not well trained, they are not well groomed. To what extent will you be able to say they have reached that level of competence expected to administer the treatment? If you cannot say that, then you'll have introduced what we call treatment verification threat to the study. Now, to the procedure. You assign your subjects to groups, experimental and control. It can be more than two. We are going to see some of this design very soon. Of course, I said you must always manipulate the independent variables. The control, you must always control the confining variables. All those threats we have mentioned, they are brought about as a result of those confining variables, which must be under perfect control for you to have a very good finding. Now, to the types of experimental studies. We have basically three types. We have the pre-experimental, or what we call the pseudo-experimental. Then we have the pure experimental, as well as the quasi-experimental. The pre-experimental is not something to be used, but in teaching, we always start with it to take the student mind through a progression until we get to the pure and, of course, to the quasi. The first one is talking about a group. You give treatment and you observe. The second one is also about a group. You first test You give treatment and you observe. The third one is talking about two groups, or no pretest. There will be treatment, and of course, the two groups will be tested. These three types of diagrams, they are liable to almost all the threats I have earlier mentioned, both for internal and for external validity. The pure experimental. I want to say that we have about 16 designs for pure experimental and quasi-experimental. But I am going to discuss with you those that are commonly or frequently employed in research. The first one is what we call the two groups randomized pretest. The title speaks volume. Two groups, we have two groups. Randomized, your subject selected by randomization. Pretest, you first carry out or conduct a test before the treatment. Then X, the treatment. C is the control. Then the observation again is the post-test. I want to say here that when you are reporting, please always ensure that the control is also reported. What you have given to the control. You don't just leave them without any teaching. But because it's not what you are investigating, so you don't call it treatment. And that is why here, you don't see me put dash. In some books, you see them saying dash as if nothing has happened. Something has happened. Maybe your usual conventional method against X, which is maybe guided discovery, and you now want to see the efficacy of guided discovery and all that. Of course, like I said, inherent statistical tool. In this case, you get the gain score, the mean score of the post-test, or the of the experimental and control group. You get the difference. And when you get the difference, you analyze through a t-test. If you like, if you get the mean score of the difference of the pretest, then you employ analysis of covariance. The second group, of course, from the logic of the first, no control. And how do you analyze data? You analyze data here by ensuring that you find the mean difference and, of course, of the post-test, and you subject it to t-test or to analysis of covariance. In the third one, this presupposes that you have three groups. It's just an extension of the first one or the second one, as you may want to see it. So how do you now analyze your data? You analyze your data by finding the mean difference of the experimental and the first control, or of the experimental and the second control. And of course, you analyze using analysis of variance. The fourth one is what we call the Solomon 4 group design. Here you have 4 groups. This is a very good design, and I want to say is most often employed in psychology. Those in educational psychology are the one commonly employing this, because in some cases they want to look at relative effects of two treatments, and in this case they may wish to have two controls. How do you analyze your data in this case? All the tests is what you have to do, and you now apply analysis of covariance to get your finding. Now, quasi-experimental study. In this case, we have two that I want to discuss. The first one is the one commonly employed by researchers. And in this case, please watch it. You will find that there is no randomization of samples. So what distinguishes quasi-experimental design from real experimental design is in terms of sampling. In this case, you have your intact sample. In the other case, you select your sample by randomization. And of course, when you want to analyze your data here, you find the mean gain score and you use analysis of covariance. I may want to share my experience. I found out that during graduate seminar in our faculty, in most cases, you see students saying they have employed analysis of covariance to analyze their data. And when you get to the sampling, you see that samples are selected by randomization, and you may want to query that. What are you doing? Of course, the second one is the time series. This time series is not often employed by researchers, but I want to point your attention to this. That is a very good design. What does it mean? It simply means that you like your continuous assessment. You teach your normal way. The first time you conduct TA, the performance was poor. The second time, performance poor. You conduct third and fourth. After, you now bring in the treatment that you feel will perform the magic, and you now start observing again. But when you want to analyze your data, you are to analyze using the observation before the treatment and the one after the treatment, maybe with a t-test. Factorial design. I often see students, they love this word, factorial design. Anytime they come up with a design, they will say factorial. I want to say here that you only employ factorial design in experimental studies. You cannot employ factorial in descriptive. Neither can you employ in ex post facto, but it's a unique feature of experimental study. What does it mean? It means that you have two or more independent variables, and these variables are at different sub-levels. For instance, you may have ability that you want to investigate, ability level, socio-economic status. You say low, high, medium. For ability, you say low, high, medium, and against performance of students. Of course, the ability and the socioeconomic can interact to give changes in dependence. But there could be possibilities of those sub-levels interacting to also give what? To give changes in dependent variables. So in this case, you may want to look at the main effect as well as the interactive effect of those variables. This design is a worthwhile design, and anytime, any day, in most experimental studies, you see researchers employing this. So there's something I want to say here, and what I want to say is that experimental studies are not studies that are easily to conduct. Before you can conduct it perfectly, expertly, one, you must have grip of the subject matter. You must understand it. You must identify threats and be able to control those threats. If you are able to do this, the study will be fine and you'll be happy for it. On this note, I want to thank you one and all. Thank you.
Thank you so very much, Professor Olatunde Owolabi, for that very, very brilliant interaction with us. You've kept very, very well within time. I just want to make a few statements to thank you people for all that you are doing for us in math education, science education. You know, research methods Professor Owolabi has given us, taken us to the deep end, and he has refreshed our minds and given us new insights. I'm going to throw a challenge to him and to all the others in this class. In fact, the next discussion forum will be based on what I'm now going to say. The next discussion forum. Since my undergraduate days, several years back, my master's days, PhD days, on the matter of experimental designs, I've been hearing the same thing. Solomon's four-group design, all of this. I kept hearing them. Are we asleep? I'm going back now to, is Africa asleep? I'm going back now to Professor Michael Hove. He's talking about Afrocentric. He's talking about, I'm talking about Africa claiming the 21st century. If you pick the book on, if you pick Campbell and Stanley, Professor Aribabu, did you read Campbell and Stanley? Professor Aribabu, Campbell and Stanley, did you read it on experimental design? Campbell and Stanley.
Yeah, I just browsed it.
Okay, fine. You see, Campbell and Stanley and all those books, all of them. They are talking about
one of the
topmost.
Yes.
Yeah, I used that way back on the graduate, postgraduate.
Yes.
So they'll talk about all these experimental designs. Yes. Are we not in Africa able to come up with a design that will say Aribabu Owolabi design? it's about time. It's about time. I feel quite uncomfortable. It's about time we Africans, we also come up with some design. When you come up with the design, so for the next discussion forum on a Thursday, that's going to be after looking at all of these descriptive, experimental, where are the gaps? What are the things that we can contextualize? What are the gaps that we can also propose? In my lesson number 4 on statistics made easy, you find that I was talking about all the people living, what is it, Shapiro Wilk, and all of them. Exactly, Gosset, all of them. You see, so it's about time this experimental design, pick any book, use the same thing. Go to descriptive statistics, the one I mentioned to you people in my own presentation, the same thing. So it is about time we reflect. I think I should convene a meeting of all the people teaching research methods in this Nigeria. I'm going to convene a meeting and tell you people that, look, it's about time we all come up with something that is the gap. Has there not been any gap since way back? So this is just a matter of reflection, not for Professor Owolabi to answer, just to let us know that's about time we also come up with something rather than, look, rather than just drinking the thing from the Igbo people and pouring it out to our students. In my case, I told you about discrete statistics, surveys, and all that. And when I was delivering that lecture, I felt uncomfortable that we're not doing ourselves and the new generation that we are preparing now a favor. So that's just my point of reflection. So the floor is now open. Olatunde, you have the floor.
Thank you very much, sir.
Pleasure.
Thank you, Mr. Owolabi. I want to say that each opportunity of listening to you on research, I always have a lot of things to learn. Today, I need to clarification. What election bias does equivalence of group, does it directly mean that the number of students in each group should almost be equal or equal?
All right.
That's number 2. When you talk about experimental mortality, if it happens, as I said, what do I do? If I lost 1 or 2 candidates, what should I do to control it? Then under time series, I'm always confused in this area. When you say you teach a group of students, topic A, topic B, topic C, by the time you're coming back with that treatment, am I using the same topic or another topic? Because if it is one term in a school, and I've treated topic 1 for week 1, week 2, week 3, my week 4 and week 5 topic might be more difficult or more simple as compared to the previous one. Where does it come in?
All right, thank you very much. Thank you very much. Wonderful. Our Ready Professor Owolabi has noted it. Alade Okin, you have the floor. Alade Okin, you have the floor.
Thank you, sir. Good morning, sir. My question is this, sir. Is it possible for someone to combine Quasi and pure experimental in a study?
All right, thank you very much. Combination of.
This is the question again. Hello? Mr. Alade, please can you repeat your question again?
Sir, thank you, sir. My question is this, sir. Is it possible for someone to combine Quasi and pure experimental design in a study?
All right, thank you very much. So let's go on to. I hope Professor Owolabi, you got the question now.
Yes, sir. Yes, sir.
Very good, excellent. So let's go on to somebody else. Yeah, somebody from Burundi or DRC, you may wish to take the floor. Just raise your hand, and I will invite you. Okay, if there's none, I will have to yield to Michael Adewusi. Take the floor.
Yes, sir. Thank you, Professor. And my professor, thank you very much for the lecture. I want to ask, is it good for me to say experimental group is the same thing as being called treatment group?
Michael, your connectivity is poor. We cannot hear you. I go on to somebody else. Yeah. So who is next? Who else is next? We cannot hear him properly. Uh, okay. Francis, you have the floor, and then Fred. Okay, Fred. Francis is not ready yet. Fred, take the floor. Fred, take the floor.
Thank you very much, Professor Owolabi. So I want to ask, in the case of experimentation, is it the case that, for instance, we are testing CTCA for experimental group and control group? So is it the case that we are using just one topic? For instance, if it's public administration, if it's bureaucracy, I'm teaching the experimental group bureaucracy and teaching the control group bureaucracy, but using CTCA for the experimental group. Is it the case that you have to use exactly the same topics or concepts for the test?
All right, thank you very much. Fred, I'm not going to throw that question to Professor Owolabi. I want you to answer it yourself. Oh yeah, okay. Over to you. Answer it yourself, Fred.
Yeah, so I just wanted clarification, but that is my understanding of it. I think that it should be the same concept or topic,
of course,
that you use for both the experimental and then the control group.
Okay.
And then applying the CTCA to the experimental group.
Okay, that's it. You have answered the question. No, you have answered the question. That's what it is. Yeah. So who else is? Francis, if you can get your microphone to work now, please do. Go ahead.
Yes, sir. Can you hear me now?
Loud and clear.
Okay, sir. I say, Prof, in his teaching, mentioned the statistical regression as a threat to internal validity of research, of an experiment. But I didn't get him clearly. I want him to expatiate more on that statistical regression, how it constitutes a threat to internal validity.
All right, thank you very much. So on that note, that I'm now going to invite our daddy, Professor Tunde Owolabi, to. Okay, I can see Adebayo. Okay, I have a few more minutes. Adebayo, you can take the floor. Unmute yourself and roll.
Thank you very much, sir.
Pleasure.
Good morning, sir. My question is, the first slide, I think page 2 on the first slide, the mic was not, we couldn't hear the prof very well then. So maybe you can just review on that, just enlighten us on that. First picture, you have 2 plans.
No, we don't have that time. You will get a recording of this and you hear it very clearly. Please, I can't start the lecture all over again. Sorry about that. So let's yield to Professor Olatunde Owolabi to, Professor Owolabi, his citation that I read was the one he sent in for facilitators. And then he sent me one yesterday, a very short one. And I said I was not going to read that short one because he's a great man. Professor Chinzewu is laughing. He's a great man. I can't read that short citation. It was my boss, my head of department. So back to you, Professor Owolabi.
Well, I want to thank you very sincerely, sir. We are always proud of you. With your permission, sir, may I just say the second slide the person was referring to, I was only trying to give allusion to a situation where you have an experimental setup. The phototropism in those days in biology that we learned, where you have the control group and you have the experimental group. The experimental group is given the treatment. And what is the treatment? You open an end of a can for light to come in. The control group, you seal all the ends and you observe for some few weeks and see what will happen. The plant in the experimental group will always grow in the direction of the light, and the other one will just go straight. That is to show that light is very necessary for plant growth and also for photosynthesis. Thank you. Yes, Mr. Francis on statistical regression. When you talked about statistical regression in experimental studies, what you are saying is that you have 2 experts. Take, for instance, in a class, you must always have high achievers. You have those who are coming up, and you have those who are the bottom of the barrel. In conducting your study, if you decide to pick those at the bottom of the barrel, or you pick those at the extreme, excluding those at the middle, what you must have introduced into that study is what they call statistical regression. And why? You have not taken into account the ability of other students. So whatever finding you get, say for instance, you pick the brilliant one, and at the end of the day, you are not saying the treatment is very effective, all the students scored 100%. You have forgotten that you picked the brilliant. This is a very good case. There was a time in our university that a particular vice chancellor.
Professor Owolabi, you have just 5 more minutes. 5 more minutes, please,
okay,
or less,
sir.
please.
Thank you, sir. Yes, I will finish within that time. A particular vice chancellor was saying that those in medicine, they are teaching their students very well. And I responded, I said, sir, have you forgotten that those in medicine, they are brilliant students. They are very high achievers. You cannot use your teaching in medicine to judge that your teaching is good. For you to judge your teaching is good, you come to Faculty of Science, 100 level, and teach all students, then we know. So that's just that. The next, of course, Dr. Fred, you have answered your question by yourself. Now, back to Oladejo. I'm always proud of Oladejo. Oladejo is a growing scholar. There is no how you teach, and Oladejo will not want to seek clarification. Yes, selection bias. We are talking of equivalence of group. Is it by number? Well, to a large extent, I will say one, equivalence simply means the two groups are of equal ability. And when you are saying two groups are of equal ability, it simply connotes that you have also equal number of samples. They are of equal ability. So that at the end of the day, you will not say that the control group, because they are more brilliant, they have performed the experimental group, and on that basis, the treatment is not effective and all that. Then, the second question, you are talking about experimental mortality and what to do. You see, there are statistical tools that will correct that at the end of the day. However, what we are saying about the threat is, to a large extent, try and control it. Don't conduct an experimental study for 3 months or for 4 months. In the process, some of the students might fall sick and not come to some of the classes. So that's what we are saying. We are not saying that if it happens, what do you? There are statistical tools that you can use to make correction when you have confounding variables introduced in your study. Yeah, and of course, somebody, you are talking about
1 minute more. 1 minute more.
Yes,
Professor
sir. You are
Owolabi,
talking
please.
about time series. You are saying treatment. Is it same topic? Of course, you don't talk of topics in schools. You talk of concepts. If you are taking photosynthesis, for instance, you pick that concept of photosynthesis, and throughout you test, you teach, you test, you pre-test and post-test. So that at the end of the day, you say this treatment is good for photosynthesis. So it's your scope that determines this. But what you keep teaching continuously.
All right, thank you so very much, Professor Olatunde Owolabi. We want to appreciate you for a great lecture, a great explanation and answers to the questions. So it's now time to show appreciation by the presentation of a plaque, an appreciation plaque. I'm just looking for the person who will present. Yes, I've seen Professor Uchenna Nzewi. Professor Nzewi, you are going to present the appreciation plaque to Professor Tunde Owolabi, and I will set it up right now, and I will invite you. So, Professor Nzewi, you have the floor to present our appreciation plaque to Professor Olatunde Owolabi.
Okay. Lagos State University Africa Center of Excellence for Innovative and Transformative STEM Education, World Bank supported project. This is to certify that Professor Olatunde Owolabi facilitated courses ACE 811 and ACE 911, April 27 to May 2nd, 2020. Signed, Professor Peter Ukebukola, OFR. Congratulations, Professor Owolabi.
Thank you.
Congratulations, Professor Owolabi, and very well done. You've done us proud, done the center proud. It's on that note that we'll come to the end of our first lecture for today. And please stand by as we set in motion the second lecture.